When we add two matrices, we said that the two matrices we're trying to add have to be the same size. And if they're not, we can't go any further. We can't do it. For multiplying two matrices together, there is also a requirement about the size, but it's not that. It's not that they have to be the same size. In order to multiply two matrices, the number of, I'm going to name them, they're easier to talk about when they have names, so A times B, the number of columns of the first, so the columns of A, must be the same as the number of rows of the second, so the number of rows of B. If we look at A and B here, we know that A is 2 by 2, and I want to multiply that by B, which is 2 rows and 3 columns. I need the number of columns of A to be the same as the number of rows of B. So I'm really looking at the inside two numbers here, columns of A and rows of B. If those match, then we can multiply the matrices. If they don't, we can't. Good news. They match. So we can multiply our A times B. The result, when we multiply two matrices, has the number of rows of the first one, rows of A, and the number of columns of B. So when I multiply A times B, the 2 by 2 times the 2 by 3, the result will be 2 by 3. Because the result of matrix multiplication has the number of rows of the first and the number of columns of the second. So when I multiply A times B, I can do it because A has 2 columns and B has 2 rows. And the result will be 2 by 3 because A has 2 rows and B has 3 columns. Let's actually do it. I know that my result is going to be 2 by 3, so I'm going to go ahead and put in my 2 by 3 matrix. We can really only multiply two numbers at a time, so we're going to do that a whole bunch of times. When I multiply A times B, the 1, 1 entry, row 1, column 1, and the result I'm going to get by multiplying row 1 of A times column 1 of B. I'm going to start at the beginning of the row and the beginning of the column and multiply those two entries. So 4 times negative 5. If I can get my thing in the right place there. There it is. All right. 4 times negative 5. But there's more row and more column. So now I'm going to move across the row and down the column and add on. Next in row 1 of A, there's a 1. Next in column 1 of B, there's a 2. So I'm going to multiply those. And now I'm at the end of the row, I'm at the bottom of the column, so I'll stop and move on to the next. Now in my result, this is row 1, column 2. So I'm going to again use row 1 of matrix A, and this time I'm going to use column 2 of matrix B. So I'm starting at the beginning of the row and the top of column 2. Beginning of row 1 is a 4, top of column 2 is a 3, so I'll multiply those. And then I'm going to move across the row of A while I move down the column of B. I have a 1 and a negative 1 at the bottom of column 2 of B. I'm at the end of the row, bottom of the column, So I'm done with that one. We're going to do the same thing all the way across. Here's the 1, 3 entry. Row 1 of A with column 3 of B. Across the row, down the column. Now I'm in row 2. To get row 2 of the result, I'm going to use row 2 of A. This is column 1, so I'm going to multiply row 2 of A times column 1 of B. Row 2 of A starts out with -2. Column 1 of B starts out with -5. Now I'm going to move across the row and down the column. Across the row I have a -3, a -3. Down the column I have a 2. And we're going to keep going like that until we get to the end. Let's see, so next I have -2 times 3 and -3 times -1. And finally, row 2, -2 times, I'm on column 3 now, and -3 times 0. And there we go. We're not going to stop there. We're definitely going to actually multiply and add, order of operations all over the place. Multiply first and then add, and see what we get. So here again, 2 by 3 matrix. Here we go. 4 times -5 is -20. -20 plus 2 is -18. And we're just adding and multiplying. 12 minus 1. 16 plus 0. I'm just going to say this out loud. 1 times 0 is 0 and not 1. And the only reason I mention that is because that's just something that happens pretty often. It's just a slip of the brain. 1 times 0 is 0. 10, positive 10 minus 6. -6 plus 3. And finally, -8 plus 0. And there's our result, A times B. If I want to do B times A, if I'm just multiplying regular numbers, I can switch the order and I get the same result, right? If I multiply 2 times 3, I get 6. 3 times 2 is still 6. So let's see what happens if I change the order and I want to do B times A instead of A times B. Well, first we have to check, can we do this? B is 2 by 3, and A is 2 by 2, and they've exchanged places there. In order to multiply two matrices, the columns of the first one has to be the same as the rows of the second one, so these middle two numbers here have to match. Well, guess what? They don't. I can't multiply B times A. If I tried to do that, I'd be going across a row of B, so -5, 3, 4, while I go down a column of A. And I start off going -5 times 4, no problem. 3 times -2, also no problem. 4 times, there's nothing there. It's not that there's a 0 there, there's nothing there. Can't do it. So because the columns of B and the rows of A don't match, we can't do this at all. Which means we're done.